Welcome back, guys, and today I am with the chapter Triangles, chapter 7 of grade 9 maths. So, let's get started. So, what are we gonna study in this chapter? So, looking at this chapter Triangles, we'll be studying about what a congruency means, what does correspondence means, and some of the criterias of congruency of triangles, and how can we prove them? And then later on, there are some more additional features of isosceles triangles, and we will be also studying about inequalities of a triangle. So let's first see what does congruency mean. The whole chapter is talking about a term called congruency. So what does congruency mean? Congruency means two figures which are same or replicate each other in size and shape. For example, if I draw two triangles, and if I say that all the three sides are equal, which means that they are same in shape and size. And how to prove that? Normally what we do and how we use congruence practically is that we take one shape and place it over the top. If it exactly covers the other shape, then that means it is congruent. For example, if we take this triangle ABC and place it on top of triangle PQR, and they cover each other without leaving any part of the triangle seen, then that means they are congruent, which means that they have the same shape and size. So this is what is called congruency. Now what does correspondence mean? Here if we see that AB is equal to PQ, BC is equal to QR, and AC is equal to PR, which means that A is correspondence with P, because AB is corresponding with PQ, which means that A correspondence with P and B correspondence with Q. So this is how we prove, this is what is called correspondence. Now how do we write that these two triangles are congruent? We write it like this. Triangle ABC is congruent, this is the congruency symbol, to triangle PQR. Now what we must take care is that we write the triangles exactly according to the correspondence. Now if we write that triangle ABC is correspondence to triangle QRP, that's wrong, because A doesn't correspondence with Q, it only corresponds with P. So we must write the triangles according to the we must write the congruency of the triangles according to the correspondency. Now, moving forward, we will see what is some criteria of congruency. Now, when it comes to the congruency of two triangles and the criteria, it means that how are we going to prove that two triangles are congruent? So to prove, we must know the 6 parts of a triangle which can be congruent. The 6 parts of a triangle are the 3 sides and the 3 angles. So if this triangle is congruent to this triangle, if ABC is congruent to PQR, we have to prove that these 3 sides and the 3 angles are correspondent and equal to the 3 sides and 3 angles of the other triangle. But to prove congruency, we don't need to prove all the 6 parts. We can prove any 3 according to the suitable criteria given to us and suitable values of the sides and the angles given to us. So looking like that, we have 5 congruencies which we will be learning right now. So looking at the first criteria, which is the SAS criteria. So SAS means side angle side, which means that if we have a triangle ABC and a triangle PQR, then it means that 2 sides, if it's given that AB is equal to PQ and another side BC is equal to QR and the angle included in between, so which means that this angle B and angle Q, if we are given that AB is equal to PQ, BC is equal to QR and angle B is equal to angle Q, then that means the two triangles are equal or they're congruent. So what does this mean? When we write this in a form of words, we call it an axiom. We have 2 types of writing down a statement, either in theorems or in axioms. theorems are the statements which has to be proved, and axioms are the statements which cannot be proved but they are well known experimentally. Now SAS is an axiom because we cannot prove that, but we very well know that it's true. So here there is no proof for SAS congruency. But what we must understand is that it means that when we write it down as an axiom, we should write it down like this. If two sides of a triangle and the included angle. So this is the included angle. The angle in between the two sides is the included angle. So SAS states that if two sides of a triangle and the included angle is equal to the corresponding two sides and the included angle, then they are equal. So which means that if this side is equal to the corresponding side of PQ, then that and BC is equal to the corresponding side of QR, and angle B equals to angle Q, then triangle ABC is congruent to triangle PQR. Yes, because AB is corresponding to PQ, which means A and P are corresponding. And that's how we write SAS. Now let's move towards the next criteria. Now coming to the next criteria, that is the ASA, or also known as AAS. It means that if two angles of a triangle is two angles and one side of the triangle is equal to the other two angles and a side of the other triangle, then they are congruent. For example, if we have ABC again, and for example we have this angle B and angle C, and here PQR, and we are given that angle B equals to angle Q and angle C equals to angle R and BC equals to QR, which means that the two triangles are equal, because here it says that ASA means angle B is equal to angle Q, angle C is equal to angle R, and the side in between the two angles, the included side is also equal to the included side QR. So this is called ASA. Now AAS, it's also quite similar. So we have two triangles ABC and PQR, and for example if this angle and this angle are equal and we have this side as equal, so here angle A is equal to angle P, angle B is equal to angle Q, but BC and Q are not the included angle, but still if they are equal they are congruent. So what ASA or AS is the same theorem, but it states that it's not necessary that the included side should be equal. It can be any side, because we know angle sum theory. So equal to angle sum theory, if this angle is equal to this angle is equal to this angle, even this angle will be equal to this angle. Which means that if angle A is equal to angle P, angle B is equal to angle Q, then even angle C becomes equal to angle R, because the total angle is going to be 180 degrees. And if two angles are equal, then the third angle becomes equal. So using that, we can still prove it using ASA. We can again use ASA. So what does this theorem mean? It tells that if two angles and one side of a triangle is equal to two angles and the side of the other triangle, the two triangles are equal. Now coming to this criteria, it is not an axiom, which means that it has to be proved. So now we'll be looking how to prove that this theorem is true. So coming to this proof, the way we prove ASA or AA is also called proving using contradiction. So here we are going to assume and check if our assumption is correct. If it contradicts the given statement, that means that our assumption was wrong. So for here we have three cases. The case one is, for example, if we have a triangle, again I take ABC, triangle ABC and triangle PQR, and we are given that angle B is equal to angle Q, angle A is equal to angle P, and BC equals to QR. So these are the given, these values are given to us. Now we assume, let us take that AB is equal to PQ. So this is case 1. Case 1. So in case 1, we assume that AB is equal to PQ. So AB is equal to PQ. Now it is quite clear to us that the two triangles are equal using SAS. So now we can take that AB is equal to PQ. We assume. Now we have angle B equals to angle Q given to us, and now we have BC equals to QR, which is also given to us. So which means that using SAS we can prove that these two triangles are equal. So triangle ABC is congruent to triangle PQR using SAS congruency, which means that in the first case we have assumed that AB is equal to PQ, and if we take that assumption, then we can prove that the two triangles are equal. Now let us go to our second assumption, our second case. So our case 2. Now here we assume, let us take that AB is greater than PQ. So what we're doing here is that we are proving that this criteria is correct using SAS. So there are three possibilities. Either AB will be equal to PQ, or AB will be greater than PQ, or AB will be smaller than PQ. In all the three cases, we will be proving that ASA criteria is correct. Now for example, we have taken AB is greater than PQ, which means AB will be larger than PQ. Now let us construct a point called D. Now we'll construct the point D such that AB is equal to PQ. Because AB was greater than PQ, we are making a point called D such that this will be equal to this. DB becomes equal to PQ. So we construct D. We construct D such that dB equals to PQ. Now because dB equals to PQ, we can join DC here. Now we can see that this side is equal to this side. dB is equal to PQ. And again, using SAS, we can prove that dBC equals to PQR. So I won't be again showing how did we prove that using the statements again. I'll just directly write now that triangle DBC is congruent to triangle PQR. So if triangle DBC equals to PQR, then angle D is equal to angle P. Why? That's called using CPCT. What does CPCT mean? CPCT means corresponding part of congruent triangles. I already told you that there are 6 parts of a triangle, and if all the 6 parts are equal, then the two triangles are congruent. But to prove, we only need 3 triangles. But that doesn't mean that if three parts of the triangle are equal and the other 3 parts are unequal, then the two triangles are congruent. It cannot happen like that. So if we have two triangles which are congruent, it means that this triangle should overlap this triangle, and DBC can only overlap PQR when angle D is equal to angle P. So when two triangles are congruent, then every part of each triangle is equal to each other. So the 6 parts of triangle DBC should be equal to the 6 parts of triangle PQR. So angle D equals to angle P. Angle D equals to angle P using CPCT. But then that contradicts the fact that angle A is equal to angle P. Remember that at the start we had got that angle A is equal to angle P, angle B is equal to angle Q, and BC is equal to QR. So these were the given values, and but then we found out that angle D equals to angle P. But this cannot happen because angle A is equal to angle P. But angle D can only be equal to angle P if angle A equals to angle D. And how can this happen? This can only happen if A coincides with D, which means that D should come over A. Only if D comes over A, then angle D and angle A both can be equal to angle P. So using contradiction, we proved here that even if that AB equals to PQ, I mean AB was greater than PQ, our assumption was wrong. Our assumption that AB is greater than PQ was wrong. That's why we got that angle D equals to angle P. But this contradicts the fact that angle A equals to angle P. So this contradicts contradicts that angle A equals to angle P. And why did we get such a different? Why did we get a contradiction that our angle D is cannot be equal to angle P? Because our assumption was wrong. Our assumption that AB is greater than PQ was wrong, which means that AB is equal to PQ, and DB can be equal to PQ. DB can only be equal to PQ if D coincides with A, because generally angle A and angle D can be equal to PQ. So this is very clear from case 2 now that our assumption was wrong. Now let's go to our last case. So coming to case 3 now. Now we have already checked that if AB equals to PQ, then the two triangles will be congruent. Now we also check that if AB is greater than PQ, then we get that that our assumption was wrong. Now let's take the last part, the last thing left, that is if we assume that AB is smaller than PQ, which means that PQ is larger than AB. Just how we prove that AB is larger than PQ and our assumption was wrong, we can do the same thing here as well. For example, now if we construct a point D on PQ such that DQ is equal to AB, here we again get the same situation we had got in the case 2 as well. And using the same arguments of case 2, we can prove in case 3 as well that our assumption was wrong and that angle D can only be equal to angle A if D coincides with P. So only if D coincides with P, then they both can be equal to angle A. So using the same way how we have proved in case 2, we'll be using the same thing in case 3 as well. Only the changes is that we are taking a different triangle this time. So this is how we prove ASM. We take 3 cases. In the 3 cases, we take 3 assumptions that one side equals to the other side. Here we have taken AB equals to PQ, and we try to prove it using SAS. In the first case, we can use SAS, but in the other 2 cases, we find out that our assumption was wrong. And our assumption was wrong because we got a different contradicting fact from the given values. So this means that AB can only be equal to PQ, and it means that SAS stands true. Now we'll be going and checking some of the extra features of isosceles triangles which are very helpful. Okay, let's move on now and let's see some of the features of isosceles triangle. So what is an isosceles triangle? An isosceles triangle is a triangle in which two sides are equal, but the third side is not equal. So if we have A, B, C, then it's an isosceles triangle if AB is equal to AC. We know another feature of the isosceles triangle, and that feature is that the base angles are equal, which means that angle B is equal to angle C. Angle B is equal to angle C. So now we will be proving how, for example, if we are given that two sides are equal, then how do we prove that the base angles are equal? And if we are given that the base angles are equal, how do we prove that the two sides are equal? So this is how we are going to prove that two sides are equal if the angles opposite to them are equal. So let's see first. So first we will be proving that the angles opposite to two equal sides are equal. Now for example, we have here triangle A, B, C. There are many ways to prove. One way is using an angle bisector. Another way is by using a median or an altitude. Here I will be using the most simple one, that's the angle bisector. So for example, now we are given that AB is equal to AC. We are given that AB is equal to AC. Now we need to prove that angle B is equal to angle C. So we will draw an angle bisector of A, which means that this angle becomes equal to this angle. Angle BA, I'll name this as D. Angle BAD is equal to angle CAD because it's an angle bisector. It bisects the angles into two equal parts, and this is common. So using SAS we can prove this. Now let's see that. We have BC. Oh, sorry. We have that AB is equal to AC, and it's given to us, and AD equals to DM common. Um, then we have angle DAD is equal to angle CAD, which means that according to SAS, these two triangles are congruent. So triangle BAD is congruent to triangle CAD using SAS. Now using CPCT, we can prove that angle B is equal to angle C using CPCT. As I have told you, CPCT means corresponding parts of congruent triangles. So ABD is congruent to ACD. So it means that angle B is equal to angle C because each part of congruent triangle should correspond and be equal. So this is how we prove that angles opposite to equal sides are equal. So now next we'll be proving that how sides opposite to equal angles are equal. Okay, now we have triangle ABC again with us, ABC, and we'll again draw. Now here we have the angle B is equal to angle C given to us, and we have angle B equals angle C given, and we need to prove that AB is equal to AC. So we will draw another angle bisector again. So when we draw angle bisector, we'll again get that this angle is equal to this angle. So angle BAD is equal to angle CAD, and we can prove this using AAS. So this angle, and AD is common. So we can prove that these two triangles are equal using AAS. See. So angle B is equal to angle C given to us, and then angle BAD is equal to angle CAD using the construction we had done, and AD is equal to DM because they are common. So like that, triangle BAD is congruent to triangle CAD using AAS. And similarly now, we can also write that AB is equal to AC using CPCT. Again, CPCT means corresponding parts of congruent triangles. So we proved here that using AAS, these two triangles are congruent, which means that every part should be equal. So as AB is a side of the triangle ABD and AC is a side of angle ACD, and the corresponding as well, they are equal. So this is how we prove that angles of sides opposite to equal angles are equal. Now we have two more congruency criteria left, and we'll be moving on to them and see how to prove them. So the next congruency criteria we have is called the SSS congruency criterion, which the full form stands for side congruency criterion. It's a very simple one. It states that if three sides of a triangle is equal to the three sides of another triangle, then they're congruent. So if we have two triangles here, and if all the three sides are equal to each other, then they are congruent, which means that each triangle can overlap the other one. So this is a very simple congruency criteria, but we must also know the proof for this one because this is not an axiom, this is a theorem. Till now I haven't shown you people what is a formal way of proving a theorem. So now here this is the way I'm going to show you a spare model of how to actually prove theorems, and this is the way how we're going to prove all theorems. So first we're going to write what is given to us, what is already given, and we are just going to draw the diagrams. Two triangles we have A, B, C, and PQR, and we are given that these three sides are equal. So it's given that AB is equal to PQ, AC is equal to PR, and BC is equal to QR. So this is how we write. We first write the given statement to us, all the given values, and now we're going to move forward. So to prove, then we write to prove. What do we want to prove here? We need to prove that triangle ABC is congruent to triangle PQR. And now we're going to do some construction, because we cannot prove the congruency of SSS without doing some construction. So first let me show you what the construction is, and then I'll write it down. So what we're first going to do is that we're going to draw a line called PX. We're going to draw a line called PX such that QX is equal to AB and angle Q is equal to angle B. So what have we done here? We have drawn a line called PX intersecting QR. It is intersecting the QR, which means it's going to be a straight line intersecting QR, such that AB is equal to QX and angle B is equal to angle Q. So what's the construction we have done? We have done the construction. Draw PX intersecting QR such that AB is equal to QX and angle ABC is equal to angle RQX. So here we have done some construction, and now we will join RX as well. So and the next construction we are going to do is join RX. So the construction we have done here is that we are drawing a line PX intersecting QR such that AB is equal to QX, and also that angle ABC, this angle, is equal to angle XQR. So this angle is equal to this angle, and then we join RX. So we get another triangle. The dotted lines show another triangle, and now we will be moving forward to proof. So this is how we're going to prove now. Now I don't have enough space, so I will just rub this. So after writing what we have to prove, the given and the construction, we are going to write our proof. So below construction we write proof, and we're going to take two triangles now. In triangle ABC, and the next triangle we have here is XQR. XQR. And now I'm going to prove that this triangle is equal to this triangle using SAS. So how are we going to prove that? Let's see. So AB is equal to QX. Actually not QX. It's better if we write using the corresponding parts XQ. Because if we write according to the corresponding parts, then we can know how to write the congruency. So AB is equal to XQ, because angle B is equal to angle Q, we know that. So and then using construction, the reason for this is construction that we did. Now angle ABC is equal to angle XQR. I will again prefer to write it in corresponding order so that there is no confusion later on. And this is also due to construction. And the next part is BC equals to QR, which was given to us. So BC is equal to QR, which was given to us because the three sides were equal. So which means that these two triangles are equal. So triangle ABC is congruent to triangle XQR. So you see that I am writing it according to the congruency now. So A correspondence with XY, because angle B is equal to angle Q, and we know AB is equal to QX. So if B is equal to Q, then A becomes equal to X, and the leftover, that is R and C. Now I'm in space, so I will write it. So what we have here is that triangle ABC is congruent triangle XQR due to SAS. So we use SAS to prove that these two triangles are equal, and after that, so now we have that angle X is equal to angle A using CPCT. So this triangle and this triangle were equal. This whole triangle were equal. The congruent. So this angle becomes equal to this angle. So angle A becomes equal to angle X. Now let's go to the next part. The next part here is that we're going to take these two triangles. So if we take these two triangles, we can see that, so we know that we had that AB is equal to PQ, and we also know that AB is equal to XQ, because we constructed this and this was given to us, which means that PQ is equal to XQ, which means that this is equal to this. Now we had just previously I had told you that angles opposite to equal sides are equal. So these two are equal sides, and the angles opposite are going to be this and this. So let me write this as angle 1, and this is angle 2, or yeah, I write it as that. So we can write that angle 1 is equal to angle 2. If it is like that, then even this angle and this angle will be equal. Similarly, we can write that angle 3 is equal to angle 4. So similarly, angle 3 is equal to angle 4. So what we did here, we used isosceles triangle theorem. So we have two equal sides. The angles opposite to the equal sides will be equal. We call this angle 1 and this angle 2. So angle 1 is equal to angle 2. And similarly, we can tell that for the other triangle as well. So it will be angle 3. How do we say that it's the same thing? Now look, if this triangle is congruent with this triangle, then even AC is equal to RX due to CPCT. And we also know that AC is equal to PR. So which means that even these two become equal, and angle 3 equals to angle 4. So we know that now angle 1 is equal to angle 2 and angle 3 is equal to angle 4, which means that angle 1 plus angle 3 is equal to angle 2 plus angle 4. Why? Because if this and this is equal, angle 1 and 2 are equal, and this is equal, both are equal, then even the addition will be equal. So angle 1 plus angle 3 is angle P. So angle P is equal to angle X. And now we know that angle X is equal to angle A, which means that therefore angle P is equal to angle A. Again, to recap what we did here, we used angles opposite to equal sides. We know that these two sides are equal, so angle 1 and angle 2 are equal. Now we also show that these two sides are equal, so angle 3 and angle 4 are also equal. Now if we add angle 1 plus angle 3 and angle 2 plus angle 4, then even their addition will be equal. So angle 1 plus angle 3 is equal to angle 2 plus angle 4. And what is angle 1 plus angle 3? This whole angle, which is angle P. So angle P is equal to angle X here, because angle 2 plus 4 is equal to X. And we also know that angle X is equal to angle A. Why? Using CPCT of the congruency we had shown before. So because angle P is equal to angle X and angle A is equal to angle X, they both also become equal. So angle P is equal to A now. And now very easily using SAS we can prove that these two triangles are equal. Let's see. So we know that, okay, I'll write it in as it is. So in triangle ABC and triangle PQR, we have these two triangles now. AB is equal to PQ. AB is equal to PQ, which was given to us. Now we also know that AC is equal to PR, which is also given to us. Now angle A is equal to angle P. We just proved this above. So we can write proved above. I don't have it above because I don't have enough space, but we have proved above in the previous section. We saw how angle A is equal to angle P. So triangle ABC is congruent to triangle PQR using SAS. So we have proved. What was our initially we wrote what we need to prove. We needed to prove that triangle ABC is equal to triangle PQR, and we proved it with the values given that the three sides are equal. So this proof shows that SSS is true. It was a very long proof, but it was a very simple one if you are able to understand. And this is how we prove SSS congruency. Now next we'll go to RHS, which is our last congruency. So previously the first criteria of congruency we saw was SAS. In SAS we had two sides and the angle included between them was also should be equal to the other triangle. That's what we had seen. But in RHS it's quite different. We have two sides, but the angle is not included. So we have two triangles here, two right angle triangles. So what does RHS mean? RHS means right angle, hypotenuse and one side. So here what RHS says is that if we have two triangles, two right angle triangles, why right angle? Because there should be a right angle. So 90 degree, 90 degree, and we have A, B, C and PQR. So it says RHS says that if angle B is equal to angle Q, that both of them are 90 degree, and the hypotenuse, which is AC, is equal to PR, and side. So we have two sides here, two arms AB and AC, and here PQ and QR. And if they have given that any one of these two are equal, then the two triangles are equal. So what we see here, this is also a theorem, and how do we write it down? In the statement form we said that in a right angle triangle, if the hypotenuse of one triangle is equal to the hypotenuse of the other triangle, and even one side of the one triangle is equal to the other triangle, then they are congruent. And the proof is very simple. We are going to use the Pythagoras theorem, which we know. So let's see. So here we have two right angle triangles where the hypotenuse AC of ABC is equal to the hypotenuse of PQ or PR, and one side of ABC, that is AB, is equal to one side of PQ or PQ. So what are we given here? We are given that AB is equal to PQ and PR is equal to AC. Now how are we going to prove this? We are going to prove this using the Pythagoras theorem. So in triangle ABC, and here we are going to do in triangle PQR. So what is we're going to use the Pythagoras theorem. So we know that AB square plus BC square is equal to AC square. And if we take it to the other side, we want to know the value of BC now, because we know that this is equal to this. We know that AB is equal to PQ, AC is equal to PR, and if BC is equal to QR, then using SSS we can prove that. So we want to know BC. So what is going to be BC? BC square is going to be AC square minus AB square, because we are taking AB square to the other side. So BC square, this is going to be AC square minus AB square. Now we're going to check here what is about PQR. So in PQR we have PQ square plus QR square is equal to PR square. Even here we want to know the value of QR. So QR square is equal to PR square minus PQ square, because I'm taking PQ to the other side now. So we can see here that we have got the values of each of them. Now let's see the other part. So we know that AC is equal to PR. So okay, I'll just erase this so that you can understand better. Okay. Now what were the final values we had got? We had got that we had got that BC square is equal to AC square minus AB square, and we also got that QR square is equal to PR square minus PQ square. Okay, so this is what we had got. Now we'll substitute the values. So BC square equals to AC square. What is AC? AC is equal to PR. So even the squares will be equal. Now for example, if AC was 6 and then even PR becomes 6 and both of the squares will be 36. So what we can substitute, we can write PR square instead of AC square. So instead of AC square we'll write PR square because both it can be substituted, and AB square same goes here. AB is equal to PQ. We are already given this value. So even AB square will be equal to PQ square. So minus PQ square. So now BC square equals to PR square minus PQ square. And what is PR square minus PQ square? QR square. So BC square is equal to QR square because you're substituting. What is PR square minus PQ square? QR square. So BC square equals to QR square. Therefore, BC equals to QR. Because if two things are equal, then even the squares will be equal. So if BC is equal to QR, then we have that these two sides are also equal. And if these even if this side is also equal, then we can prove that triangle ABC is congruent to triangle PQR using SSS. So using SSS we have proved that the two triangles are equal. I haven't written everything again this side is equal to this side, but you can write that. So what we did here, we tried to prove that the third side is also equal to each other to prove it using SSS. So we use Pythagoras theorem, and then we substituted the values of AC with PR, AB with PQ because they both are equal given to us already. And using that we proved that BC is equal to QR, and then we used SSS to prove that the two triangles are congruent, which means that RHS holds its value. And this is where the congruency, the criteria of congruency comes to an end. There's another topic called inequalities of triangle, which I will be showing you in my next video. So till then, take care, and I hope you liked my video. Thank you.